Okay. Konnichiwa. Good afternoon, everyone. So today I will talk about some fun things because I know everyone are already tired after attending 2 days of PyCon and full of sessions. So now, today I want to talk about from data to web application, how we can recognize an anime character with transfer learning. So a bit introduction from myself. My name is Iskandar Setiadi, and I'm from Indonesia. Does anyone here know Indonesia? Yes, thank you. And currently I'm working as a software engineer in HDE for the past 3 years. And I also became a speaker of PyCon Japan last year and PyCon Indonesia last year and PyCon Malaysia this year. So this is my fourth PyCon. And yeah, let's start. So if we are talking about image recognition, we know that we already use a lot of image recognition in our daily life. For example, in China, the government already in China and the United States, there are several companies that try the self-driving cars. And some companies also trying to do with the smart home. So for example, if you are going home, the camera detects your movement and it knows that it's you and it can do action based on that. And Microsoft last year they also announced they are working on smart workplace in Microsoft Build 2017. So you can recognize where you put your inventory, where your worker is. And Apple also did some image recognition with the Face ID in the latest iPhone. And a bit history about the image recognition. If you are working in image recognition problems, probably you know a challenge called ILS-VRC, which is the largest computer vision competition in the world. And starting from around 2015, a lot of big companies like Google and Microsoft, they are using deep learning model to join in the competition. And from 2015, the deep learning has a better top 5 error score compared to human. So at that time, they compared 1,000 categories to human, and they told the human to categorize those things by themselves. And they compared it against the deep learning model, and the deep learning model achieved the better performance. It started from the ResNet from ILS-VRC 2015, which is around 3.57%. So the problem with image recognition is there are a lot of things that we need to think. For example, we need to think about the object scales, because in the 2D photos, we rarely can know what is the distance between us with the objects. So we need to know whether the object is close to us or far from us. We also need to know whether the image contains multiple number of instances. We need to know whether the object has a deformability form. For example, if it's a rubber, you can like stretch it and it's still a rubber. But if it's like a steel, you cannot, it's not deformable. And you need to know like the real world size and so on. So the background is about this topic is like one day I took a shower, and you know that shower is the best place to get an inspiration, right? So I'm starting to questioning about my life. Okay, no, not that far. I'm starting to questioning how we can detect an image out of like an anime 2D image and recognize which character is actually this character. And moving from that story, I tried to Google several sources. If you know anime, you probably know a URL called sourcenow.com, where you upload a 2D image and it will give you which creator, like which pixie or which like domain actually contains this image. But the problem with SourceNow and the similar solutions is that it cannot properly detect a crop image. So in case you crop an image like below, it already cannot detect the character or like which illustrator actually drew the image. And there's also a problem with edited image, because sometimes you want to edit you got an edited image and you want to know which character is it. And there's another problem with an indexed image, which is not in, like a new image, which is not yet indexed in the system. So move from that on, I think I will not say about what is machine learning. I guess everyone here already know what machine learning is, right? Does anyone here doesn't know machine learning? No, thank you. So let's skip machine learning introduction. Let's go deeper. So we will talk a bit about deep learning. What is the difference between traditional machine learning and deep learning is basically with traditional machine learning, if you increase the number of training iterations, you will eventually get stagnant at one certain point. So the proposals is basically in the deep learning, you add more layers. But the other problem is deep learning is usually, of course, more slower because you add more layers. And in image recognition, there's a certain techniques called convolutions. So you have a filter like this image. And from that filter, you try to compare it with the original image, and you get the visualization of the filter that it detects. So it's like a matrix of number, basically. And you have a convolve feature that tries to detect, for example, the edge of the image. So internally, what it looks when you run a deep learning model against an image is like this. So in the deep learning model, first it tries to extract the low-level feature, and after that it will go to the mid-level feature, and it will get the more clearer image. For example, it's actually a round, or it's actually how do you say? Like a clear object representation as a high-level feature, and you got the trainable classifier later on. And yeah, step one, we need to prepare the data before we can run it, right? So for myself, because I'm not actually working in machine learning is just my hobby, so I need to install the TensorFlow first. And in Python, you can do that easily with pip3, install TensorFlow, or if you have a GPU, you just run the TensorFlow GPU pip install. So now we already know what deep learning is, and the question is, why should we use transfer learning? So the problem is with anime characters, this is the resource from the top 5 characters indexing website. And I picked like one randomly, and I checked the data there. They have like around 35,000 registered image. But the problem is most of the images, most of the characters have a limited number of images. So the top 1,000, like the most popular 1,000 characters have like more than 70 images, but the 2,000 characters only have 40 images. That's why at this point we decided that we need to use transfer learning to solve this problem. And yeah, this is actually the hardest part, because you need to prepare the raw data, which is you need to find like 10,000 images. You need to scrap the data. You need to clean the data manually. I think it took me like around 3 weeks to scrap and clean up the data manually, like tag this to this character, tag this to this character. But the thing is, I cannot really go into details because scrapping anime characters are illegal, you know? So if you need help, let's talk to me later. And if you know, like several weeks ago, yeah, unfortunately or fortunately, this is released by Google several weeks ago. Google released something called Google Dataset Search in the toolbox.google.com. So if you go there, you type anime character, they actually provided you quite a large collections of dataset that you can use. And this one taken from Danboru 2017, which is hosted as a Kaggle challenge. And you can, if you are interested also working in this project, you can go to the Google dataset. You can type like anime characters and download the datasets there. Yeah, this is a very useful tool, especially if you are working with machine learning and deep learning stuff. This is a very useful tool to find a dataset, because that's probably the hardest part that you need to prepare in the beginning. So the next step is we want to analyze the problem. So of course, as like a machine learning beginner, I thought, okay, this should be an easy problem, right? I should just run a face detection because it's an anime character. It should look like a human, right? Nothing probably goes wrong. So I tried to use something called an OpenCV, which is, and I downloaded a 3D model from the internet. And the result I got, I tried to upload a normal human face, like photo with human face, and it can detect the image properly. But the problem where it goes wrong is when you upload an anime character image, it detects almost nothing, and a lot of characters are detected wrong. So back to the question, then I investigated why it doesn't work with a 2D image. First, because in anime characters, the characters probably usually doesn't have a nose, right? If you notice, like anime characters, they don't really have a nose. So in human being, there's like 67 points of facial points that it usually uses to detect your face. It tries to know like what is the distance between this point, and this point. And when you run the deep learning model, it can learn based on these features. So the problem is, yeah, we need to train a new model. So fortunately, if you are also working with these kind of things, you probably know a GitHub user called Nagadomi. He already provided a LBP cascade classifier to detect an anime face characters. So when I run it, okay, now it works. It can actually detect where the face is. So when I tried to run it with the human face, it cannot detect anything. So okay, so our hypothesis is correct so far. Now we already know how to detect a face out of an image, and we also know that full layer deep learning requires a huge data set, and it takes weeks to train. For example, in Google Inception V3, which they used for the ILS VRC challenge back then, they took like 1 week to train. This is Google. If you run it in my laptop, it probably takes 1 year. So it's impossible to run it locally unless you have a lot of GPU resources. So we will talk about a bit about the transfer learning. So the deep learning model from Inception V3 looks like this, okay? It tries to detect the edge here, and then after that, it goes to the mid-level features, which is shapes, and it got the high-level features there before runs it through the classifier. The idea of the transfer learning is we only want to retrain several layers below, around here. So you only want to train that part. So the first step is you got an image. From the full image, you want to detect which faces this image contains. And after that, you need to resize it to a certain size, like 256 times 256, to let it run through your deep learning tools. And after that, you can do the transfer learning for several layers before you classify the things. So what we want to do here is we want to retrain the dropout layer, the fully connected layer, and the softmax layer. So for the dropout layer, you are trying to drop out the units to prevent the overfit. And after that, you want to retrain the fully connected layer where you want to extract the global features, and every node will be fully connected to the preceding layer. So you will get like squared, and basically it goes to everywhere, like 1 to 1, 1 to 2 to 1 to n, 2 to 1 to 2 to n. And the softmax layer is the important part where you want to squash the final layer to make a final prediction, which sums out to 1. And for example, if you have two classes, and if class A has the value of 0.95, then the class B needs to have a value of 0.05. So yeah, if you use by the way, I'm using TensorFlow to do this. So if you use TensorFlow, you can rebuild the retrainer very easily with the Bazel build TensorFlow and do the retrain things, and you point out where your directory is. And the thing is, you can add, because our data is small, so you probably need to do the hyper parameters. So you need to adjust like the distortion factor so it has more data set. For example, you can add the brightness, you can rotate the image, you can do everything to add the number of data set that you have, and you want to try to find which learning rate is the best for your transfer learning. You want to find what number of iterations is the best for your transfer learning, and so on. And this is probably the problem of all people who are working with this kind of things. You have a migraine, hypertension, stress, and working with classifier is basically all your head just exploded. So now I will talk a bit about the original ImageNet, which is created by Google back then. So if you see from the graph over there, you can see that when you add the number of training images like from 10 to 100, actually it kind of improved your accuracy like quite a lot, right? Like 5%. But when you added it from 100 to 1,000, it's only increased by 2%. So here we have like a trade-off between low number of images will produce bad accuracy, but huge number of image also, actually it will not improve your accuracy a lot. And there's also more problems that you need to prepare the raw data, which is very hard to do because you need to clean the data by yourself and so on, except you download a ready built data set by other people. And now, after doing these things, we got the model. We want to serve it as a web app. And by the way, I did this like around December last year. So I created an application called MoeFlow. Actually, it's the name from TensorFlow. Skip the tensor, add the Moe inside it. And this is actually built with Scenic. Back then, I didn't know that Scenic has a problem. But okay, anyway, Scenic is good for prototyping. But if you want to use Scenic in production, be careful. It has some memory handling issues. Like I just know it like several months ago. And while training your model requires a huge number of GPU, you can just reuse your retrained model in the small resources. And for example, I'm hosting this in AWS, and I only use the 2 small instance. And what it does is basically it runs a face detection with the OpenCV. Then it resizes the image to a fixed proportion and run the classification through the TensorFlow model that I've retrained before. This is basically how the code of the web app looks like. It's basically load the TensorFlow model to the system, and okay, it's already initialized, and it just need to wait for the request. And to classify the image, it's also basically simple. You can read it in almost all TensorFlow tutorial. Basically, you just need to get the model, you need to get the label, and after that, you get the image and run the classification there. So for example, when I run the classification of this character, it knows like the character this image has a height of certain image, has a width of certain things, and resize the image, run the classifier, and you get a result there that this character is Teresa Rize with accuracy with the probability 0.894 something something. So does anyone know this character? No one wants to answer, okay. So yeah, let's have a bit of demonstration. So the website looks like this. I'm not good with front end, sorry for that. And for example, you upload like an image. Let's hope the internet works. Does it work? Oh yeah, it's waiting. And yeah, you get the result there. For example, I took the photo like several hours ago from my Pasmo card. And this card. And it can detect like which character it is, and it knows like probably this character is this. And let's say you have multiple characters in one image. Yeah, the problem because I hosted this in my own instance, which is a too small instance, it's kind of slow, unless you want to like give me some money so I can run it on bigger instance. So let's say I have like more than 1 characters, it will basically split it tries to detect how many characters are there before running the classification to each character. Are these correct? Yes. And the problem is with these kinds of thing, because I tried to rerun my model based on the face detection first, it has a problem if the face cannot be detected properly. So for example, I have an image like this, it cannot detect the character which face to the sideline. Yeah, I'm not like a professional in this thing, so if you like want to work with this, yeah, you can improve this kind of aspects, of course. So yeah, this is the Google Dataset search that I talked before. It's actually very good. So if you go there, it can give you like a lot of data sets. And okay, let's go back. We already talked about this. In case the internet are dead, I just took a screenshot first. And now we will talk about the other projects. If you know a project called Illustration to Facts, where it tries to basically extract the semantic feature vectors from an anime character image, so it can detect which character is this based on the text, like the text has the hair color of blue, has the eye color of purple, for example, and so on. And there's also a tutorial, a very good tutorial from the Chainer. If you are using Chainer, there's a tutorial called Chainer plus illustration to facts. So basically, yeah, this is the Japanese one. So it's also written in Japanese. So I think it's very good for you to take a look, and you can read it in detail, because I want to say I don't understand Japanese, but actually there's an English documentation for that. So yeah, you can take a look into this project too. And okay, let's continue. So I built the MoeFlow like 6 months ago, like January or February. And after that, I tried to investigate several platform as a service. If you know, there's Clarify, there's Azure Custom Vision, and it's currently still in beta. And there's also Google Cloud Auto Machine Learning, which is also in beta. I tried to, yeah, this is Amazon, because I'm using Amazon, right? So I tried to upload it to Amazon, and this is the same problem as before. It cannot detect the face properly. So basically, this doesn't work. Amazon recognition doesn't work. So I went to Clarify, and in Clarify, now it works. It also provides you with a good matrices to show you like which image is mistagged and so on. And I also checked the Python API from the Clarify. They also have a very good API support. And from Google Cloud Auto Machine Learning, this is basically new, and this is very interesting because it's made by Google. And the Python API also looks like very simple. You can just from Google Cloud, import the AutoML version 1 beta and try to run it against your model. So for the quick comparison, actually my model doesn't work. They have better result for, like Clarify, they got like 95%. Google Cloud AutoML, they got 93%, which is, I guess, their model is based on the same Inception version 3 model that I use for my transfer learning. So when I check and I compare the result, it actually kind of fails on the same test data, except they have better performance now. And the model that I built myself is like only 88.6%. Okay, let's be fair, because I'm not a machine learning expert, so yeah, let's use their products. Anyway, and for Azure Custom Vision, it's only like 77.4%. Yeah, I mean, it's Microsoft, so what can you expect? So next, this is how when you upload an image to the Clarify, they provide you with details, like which character it is, and they provide you with a general text. So it gives you like feedback, like this is an illustration, and there's a woman in the image. And this is how the UI looks in the Google Cloud Auto Machine Learning. Currently, it only gives you the top 5 label predictions. So it doesn't give you a text, like a general text like in Clarify. Yeah, I mean, it's still in beta, so it's kind of understandable. And basically, this is the result when I upload it to my system. It can basically get the prediction correctly with the probability of 0.548. And this is how it looks in Azure Custom Vision, where it it cannot detect the characters properly. And yeah, so the question is, when should we use a platform as a service for image recognition problem, if we have one? So from my perspective is, image recognition is not directly related to your main business, and you don't want to invest too much time or money on this kind of problem, then you need to use platform as a service, because preparing the data set, cleaning it up, training, and serving it, it takes too much time unless you are ready to face with those kinds of deep learning problem, then it's probably not a good idea to do it by yourself. And the next one is, unless you need the capability to customize your training model. For example, that you are not satisfied with the result, you want to build your own model, then you don't need to use the platform as a service. And of course, if you use platform as a service, they tends to be more expensive compared to running your own server. So in the long run, it's actually a good investment to build your own model. But of course, it's case by case. It depends on your use case. And you also need to, of course, compare which platform as a service is the best for your use case. Because each platform as a service have their strengths. Some of them are good to like single versus the multi objects. For example, you want to detect a single object or a multiple objects in an image, and you also probably want to like how many text that you need from an image, and you want to compare like the top one or the top X accuracy, and of course the cost. So some closing remarks from me. Yeah, what I learned from building these things is image recognition is basically a never-ending development, because you have basically a lot of problems. For example, in anime characters, it's kind of hard because it depends on the illustrator. Like anime is basically a freestyle art, so it totally depends on the illustrator, and you also have a problem with a noise in your image. Sometimes the image is rotated, and the face expression also very like important. Sometimes they close their eyes, they open their eyes. And some characters in anime have multiple forms. For example, if you know like Fat Zero and Fat Say, the saber. Saber have like multiple forms, right? So in those cases, you need like to specify this saber is from this saber is from this, which is very hard. And there's also a problem with brightness and contrast, especially if you take it like from a photo. Brightness and contrast plays like kind of an important role there. This is also another example how you can fool a neural network. For example, for human being, the teapot looks the same, but actually there's a certain pattern inside it that you can just put the pattern and it detects it wrongly. So now it cannot detect the teapot anymore in the right image, even though it looks the same for a human being. So yeah, from this talk, basically what I want to say is if you have some idea about the image recognition, you can use what I have learned here, and you take home and you can generalize the idea to solve your own problems. I hope it's helpful for everyone here. And if you want to check the project out, I've already put it in GitHub, and the presentation slide is also available in my website, freedomofkema.com/pycongp2018.pdf. And there's also a curated list which are very good for a learning material from Awesome Deep Vision and a year in computer vision. Yeah, you can check the URL later on. And self-promotion. Since I'm working in SD, if you are interested and if you are like, especially for foreigners, if you want to work in Japan, we also accepting a global internship program which leads you to a full-time offer. And if you became a full-time in our company, your proposal got accepted in any talk conferences, the company will handle the rest for you, which is very great. And we already also have like a lot of interns in our company, like more than 50. So yeah, thank you.
Thank you for presentation. We can one question. Anyone has a question? 誰か質問のある方いらっしゃいますか？
多分大丈夫。
はい。大丈夫ですか？
アニメのキャラクターの識別をアニメのキャラクターの識別を学習させたということなんですが、その教師データというかデータはどうやって作りましたか？
データの
アニメのキャラクターのデータをたくさん作った。
The data, right? The raw data. Yeah. So that's the thing here. Actually, yeah, I scrap the data. Like you can use any kind of scraper to scrap the data, right? And after you scrap the data, you need to do the tagging, like this character, because you need to tag like which character this belongs to. And of course, I created it before manually by myself, but actually right now, when I go to the Google Dataset search, Danboru, if you know Danboru, they also provide data here. They already provide like 2 million images with 77 million tag instances from May 2005 to 2017. So you can go to this Google Toolbox and you can download the raw data by yourself if you want, and you can try to do the same thing, which is almost similar with what I'm doing right now.
はい、あれですね。彼個人は最初はウェブスクレーピングでデータを収集したんですが、その過程は著作権とかっていろいろ出せないんですけど、今は Google データサーチの方でアニメキャラクターズで検索すると Kaggle のデータセットなどヒットするので、そちらを使うのが楽にできるということでした。はい、
ありがとうございます。
それでは、このセッションを終了させていただきます。発表ありがとうございました。